Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to start a new topic of discussion which is on satellite communication. Okay, for this video, firstly, I will do a quick introduction. What is actually satellite communication? Next, okay, I'm going to discuss the advantages of using comms via satellite. In fact, there are actually 6 advantages when we actually use satellite communication. Last but not least, okay, I'm going to share the history of satellite communication. So all these are the objective of this discussion. This is actually the part 1 series discussion on satellite communication. So guys, if you're keen to know more about satellite communication, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on satellite communication. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are also welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. Guys, just give me a few seconds by press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand what is actually a satellite communication. Okay, a satellite communication is actually a orbiting artificial Earth satellite. From this diagram here, you can see that this is actually a satellite. You can see that they basically rotate around the Earth. So this is what it means. A communication satellite is basically a orbiting artificial Earth satellite. They actually receive a communication signal from a transmitting ground station. Okay, so basically this is a transmitter. Okay, so this is actually a receiver. The satellite actually receive, okay, so-called a transmitting signal from the ground. Okay, so the satellite receive the signal, they probably will amplify the signal. Okay, why? Because later on they are going to send the downlink. So in order to be possible to send this downlink, they need to amplify the signal before it go to a long range again. Okay, remember when the signal travel from the ground station all the way to the satellite, the signal probably will be very weak. So therefore, the satellite probably will amplify the signal before it actually so-called send down the message to the another ground station. They may also possibility to process the data. So basically, in short, they will definitely amplify and they may even process the data. And after that, they will transmit it back to the Earth, okay, for reception by one or more receiving ground station. In short, the satellite may transmit to at least one or maybe two or more so-called ground station. Communication information neither originate nor terminate at the satellite itself. You can see that message don't actually start from the satellite. Message also don't end at the satellite. All the message start actually at the ground station and the message also end at the ground station. So in short, over here, you can see that the satellite in fact act like a relay. So what they do is basically they pass the message from one ground station to another ground station. So basically, this is what it means. The satellite act as an active transmission relay, which is quite similar to the relay tower, which is used terrestrial microwave communication. So basically, this is the quick definition of satellite communication. Satellite communication actually play a vital role in the global telecommunication system. Okay, now we have about more than 2,000 artificial satellite orbit the Earth. Okay, what they do is basically they relay the analog or digital signal that basically carry voice. Okay, for example, our voice when we actually make a phone call. Okay, it can also carry a video. Okay, for example, a TV streaming, a football match. Basically, this all like a video, and they may also send the data to and from one or many locations worldwide. Satellite communication are now an accepted part of everyday life, okay, as evidenced by the antenna or dish that dot city and country horizon, or the nearly instantaneous global news coverage that is actually taken for granted, okay, particularly in time of international crisis. Okay, you can actually see those so-called antenna that receive the TV program. Okay, they actually have a lot of dots so-called along the city. So basically from here you can see that satellite is basically an accepted part of everyday life now. Next, I'm going to share with you the 6 advantages of satellite communication. Okay, the satellite communication actually offer numerous advantage. Okay, they also have disadvantage, but the advantage outweigh all the disadvantage. Hence, this make it a very essential technology for global communication. And there are actually 6 benefits. The first one is satellite communication probably will be the one that enable global coverage. Okay, as long as you can look up in the sky, you will be able to see at least one satellite. So basically with this, you can imagine that it is almost possible to have a global coverage. Okay, satellites actually provide widespread coverage, enabling communication in remote and rural areas that are hard to reach with traditional ground-based infrastructure. Imagine this in a remote or in a rural area where there are just many handful, just simply a handful people living, okay, which means that it doesn't make any sense to build, for example, a cellular base station over there. And hence, because of this, okay, the only way to establish communication will be via satellite. Okay, so this makes them vital for connecting region where other method of communication are impractical. Okay, so basically the first one, satellite probably will be the only one that can provide global coverage. Next, on the reliable connectivity, satellite systems are highly reliable for communication, okay, as they are not susceptible to issue like power outage, nature disaster, or physical damage. Okay, for example, from time to time, you can see that, for example, our so-called service provider, cellular service provider, they may have power outage, which means that they have power issue. And once they have this kind of issue, then you are not able to send your message through the base station. So this is one issue. The base station actually use power, and this potentially have some issue when we actually has power outage. Nature disaster, again, you can imagine that because of the nature disaster, for example, the earthquake, all those so-called telecom setup infrastructure may be affected. And hence, because of this, we are not able to have any form of communication. So hence, the only form of so-called communication now will be probably so-called satellite communication. Okay, once you have this nature disaster, just imagine earthquake, okay, all the cellular base station, they are all collapsed, and hence you will not have any form of communication. And the only way of communication will be purely satellite communication or physical damage. Okay, so physical damage, like for example, like I mentioned with the nature disaster, okay, if there is some damage to the base station, etc., this may have some issue. Okay, so this actually ensure continuous service in region with difficult terrain or during emergency. So hence, okay, during emergency, satellite communication is probably the only form of communication, okay, that can link the helper, okay, or the rescuer, okay, to the rest part of the world. High data capacity. Okay, satellite can transmit large amount of data over long range, which means that satellite is also suitable to carry a lot of data. For example, video is actually considered large amount of data, and they can send over long range in terms of 100 km away. Okay, so basically they can support service such as television broadcast, internet access, and voice communication with minimum latency and also good quality. Okay, so this is the 3 advantage. The fourth advantage is basically satellite can provide a broadband internet access. Okay, satellite communication, they are actually very critical for providing high-speed internet access in remote area. Okay, for example, the ship at sea. Okay, so basically the ship at sea, there is no base station to serve them. So hence, again, the only mode of communication will be through the satellite communication, or maybe the aircraft in flight. Okay, so basically the aircraft is flying in between countries. Okay, so because of the large separation, okay, there is no way that we can put a base station, okay, to serve the aircraft user. Okay, so hence, again, the only mode of communication probably will be satellite communication. And last but not least, I guess maybe not so much on satellite communication using moving vehicle, for example, car. Okay, so basically, this moving vehicle can be served by so-called different base station, etc. So basically, not mainly on this. Okay, so basically, this is not that valid. But imagine if your vehicle move in a rural area, then the only form of communication will be satellite communication. Okay, so this is especially important. Okay, where fiber optics cable or other infrastructure cannot be reached. Cost effective for remote location. Okay, earlier on I have mentioned that if you are at a remote location, okay, where there are not many users, the so-called the feasibility of laying all the cables, etc., or construct physical communication tower can become very, very expensive because you are going to serve just only a handful of users. Hence, it doesn't make any sense to do this. So, hence, again, satellite communication will be basically the cost-effective alternative to establish communication network without the need for complex ground-based infrastructure. Last but not least, reduce interference. Since satellite communication rely on space-based infrastructure, okay, it is less likely to be affected by all kinds of interference, for example, the weather condition or other environment factors that ensure more stable communication. Next, okay, so this diagram here show a very simple satellite block diagram here. So this in yellow is basically the satellite. You can see that this is actually the ground station, okay, that basically transmit the uplink message to the satellite. So over here you can see that the satellite will amplify the signal through the TWT amplifier. After that, they actually generate this downlink signal to send a message to another ground station. Okay, so basically, in short, this is a quick satellite communication block diagram. Let's come to the history of satellite communication. Okay, the history of satellite communication marked by significant technologies advancement and milestone. Okay, here's is an overview of the key event and development in satellite communication. Okay, so everything start with the theory. The very early theory foundation is actually by this guy, which is the Arthur Clarke. Okay, basically he has a vision. Okay, at 1945. Okay, basically he had this vision to use the concept of using satellite for communication that was first proposed by British scientist, okay, the Arthur Clarke. In his paper published in Wireless World, Clarke suggests that geostationary satellite could serve as relay station for transmitting television signal, a concept that later became the foundation of satellite communication. Okay, so this British scientist basically so-called pen down his so-called his idea to make use of satellite to provide a form of communication, for example, transmitting television signal from one location to another location. The dawn of the space age. Okay, as the space race between United States and the Soviet Union intensified, okay, interest in space technology actually surged. Okay, this period saw the exploration of satellites technology for military. Okay, so at that time, mainly is for military and also for scientific and communication purpose. Okay, so at that time, probably majority of this so-called form is actually for military purpose. After that, it is widely used in military, then it become a form of communication, okay, so which is known as satellite communication. Okay, the first satellite, okay, which is known as the Sputnik 1, okay, which is built in 1957. Okay, so this is built by Soviet Union. Okay, basically they launched this Sputnik 1, okay, the first artificial satellite, okay, marking the beginning of the space age. Okay, although its primary purpose was to demonstrate space exploration capability, it also highlight the potential for communication from space. Okay, so Soviet Union launched the first satellite somewhere in 1957. The key idea for them to launch is to show their power, okay, for space exploration. However, with this actually highlight the potential that we can have some form of communication using the satellite. Next will be Telstar 1. Okay, so basically at 1962. Okay, so this is the first commercial communication satellites, Telstar 1, okay, which was launched by AT&T in partnership with NASA. Okay, it successfully relayed live television broadcasts between the United States and Europe, okay, marking the first use of satellite for television and telephone communication. Telstar actually revolutionized the global communication by enabling real-time transmission over long range. So in short, Soviet Union demonstrate the first so-called exploration at the space. So the first application of satellite is basically by this company from AT&T together with NASA. So the first thing that they actually do is to have a live television broadcast from US all the way to Europe. The early communication satellite, okay, following Telstar, another satellite such as Syncom 3, okay, which is at 1964, and also we have this early bird, okay, which is done by Intersat One, okay, which is happened at 1965. They were actually all launched. Okay, so this satellite significantly advanced the infrastructure for global communication, improving the quality and also the reliability of signal. So from here, the start off, okay, to so-called to have a relay for live television broadcast, okay, from US all the way to Europe. After that, we have more and more other companies that come into the early communication satellite. Next, the growth of satellite communication. Okay, so basically the geostationary orbit and global coverage can happen at 1970. Okay, the adoption of geostationary orbit, okay, which is approximately 36,000 kilometers above the Earth, can mark a significant milestone in satellite communication. Okay, satellite in this orbit appeared stationary relative to Earth's surface, enabling continuous and reliable coverage over specific region. Okay, so basically when you actually have this geo, okay, which means that the satellite will always appear at this particular region. And because of this, this actually so-called sparked off the interest of doing satellite communication. Next, on the Intersat and COSAT, okay, which is at 1970, okay, the International Telecommunications Satellite Organization, okay, which is known as Intelsat, okay, established in 1964. They began to provide worldwide communication service in the 1970s. The expansion of satellite communication network actually facilitate direct television broadcast, international telephone call, and also data transmission. Next, for the mobile satellite communication, which happened in 1980, okay, which means that your mobile phone can actually so-called send the signal all the way to the satellite communication. This actually happened in 1980. The 1980 actually witnessed the emerge of mobile satellite service. Okay, so early on, all these can be used by just company, but at the 1980s, okay, first form of mobile satellite service, this enable user to communicate while on the move, okay, irrespective of location. Okay, during this period, the GPS initial developed for military purpose become available for civilian use. Okay, so basically this is a short history. Next, on technology advancement and also the commercialization, which happened at 1990s. Inmarsat at the 1990s, okay, actually they began to offer satellite-based mobile communication service for voice, data, and also fax transmission to remote and maritime location. Okay, this innovation actually makes satellite communication more accessible to user across ocean and in remote region. Global Star and Iridium, okay, the 90s actually saw the launch of these two major satellite constellation, Globalstar and Ethereum. Okay, basically these companies actually aim to provide global mobile communication coverage through network of LEO, okay, which is the low Earth orbit satellites here. The direct broadcast satellites, which is also known as DBS, okay, the introduction of direct broadcast satellite system, actually such as direct TV and dish network, okay, they basically revolutionize the television consumption. Okay, this service deliver digital satellite television directly to the consumer home. Next, on the point number 5, let's come to the modern era all the way from 2000s to now. Okay, the advancement in high throughput satellite, which means that more data can be sent through the satellite communication. In the 2000s, okay, the development of this high throughput satellite significantly increased data capacity. Okay, this satellite deliver high speed internet, broadband service, and enhanced communication capability, particularly benefit rural and underserved area. Okay, satellite internet. Okay, so the emerge of high-speed satellite internet service become a very important development in a global communication. Okay, company like Viasat and HuggieNet, okay, they actually began to provide satellite broadband target remote and rural area, okay, where this internet infrastructure is not possible. Next, also under this point number 5, under this modern era, okay, we have this LEO, okay, low Earth orbit satellite constellation. Okay, in the 2010 initiative by SpaceX, Starlink, and also Amazon project, Cooper actually start to launch their constellation of low Earth orbit satellite to offer global high-speed internet coverage. Okay, so this is actually the nearest to the Earth, okay, which is the low Earth orbit. So from here, you can see that SpaceX and also Amazon actually try to provide so-called uh, a network, television network, okay, for rural and also undeserved area here. Okay, so they also offer lower latency as compared to traditional geostation satellite because they are nearer. So therefore, the latency is also shorter. Advance in communication technology, emerging technology like 5G are expected to enhance satellite communication service by integrating satellite networks into the broader 5G infrastructure. Additionally, quantum computation, okay, basically you have this quantum communication satellite, they are being explored to enable ultra secure data transmission. Okay, so this is under the modern era. Next, let's quickly understand, okay, what will be the future direction? Okay, the miniaturizations of satellite, how to make the satellite become smaller, and also the reduction in launch costs have enabled more companies and organizations to deploy their own satellite constellation in LEO, okay, which is the low Earth orbit, have the potential to revolutionize global internet access, particularly by providing connectivity to remote area where all this infrastructure is unavailable. So for those underprivileged, which you don't have any base station to serve you, okay, basically this LEO, okay, satellite can be potentially to help you to resolve the connectivity issue. Advance in inter-satellite link, okay, which is known as ISL. Basically, they are enhance the efficiency of satellite network, enable direct communication between satellite for improved service continuity. Next will be the research into quantum satellite communication and optical communications technology. Okay, so all this actually pave the way for ultra secure communication channel and faster data transmission speed. Okay, so basically these are all the key so-called history of satellite communication. Okay, before I continue, guys, again, I'd like to urge you guys to help this channel by like this video. If you have learned something from this video, please consider to subscribe and turn on your notification bell. Once again, thank you so much for some support. Let's quickly understand, okay, so what is possible? Satellite actually service, what they actually include. Okay, firstly, satellite communication actually include some form of communication coverage to remote rural area, okay, where laying cable is not practical or very expensive to do this. Live TV broadcasts, okay, such as World Cup, F1, etc., you are able to see almost live TV broadcasts from different part of the world. Next will be the weather satellite. Okay, basically the weather satellite is used to predict weather, any so-called nature disaster like tornado, etc. GPS, okay, so I think nowadays, okay, we can't live without GPS. GPS actually guide us from one place to another place. So basically, GPS is used to locate object on Earth, okay, locate the nearest available taxi, etc., for military use, for navigation aid, etc., okay, for providing a common reference time synchronization, such as used in cellular communication. Okay, last but not least, okay, so-called the bad effect of using satellite communication is to spy somebody. Okay, so satellite actually can use to have an image, okay, to spy, for example, a country, etc. So this is so-called the drawback of satellite communication. Overland wireless communication links are always limited by line of sight blockage of the signal, okay, due to mountain, due to building, etc. Okay, for example, this is a transmitter, this is a receiver. Most of the time, we will not be have this so-called line of sight. For example, let's say there's a building here, there's a mountain here. So basically, the direct line of sight is actually so-called block. This is what it means here. Okay, so therefore, we can set up an intermediate relay station. So if we transmit all the way up, then we will not have anything that block in between the transmitter and receiver. So basically, if we are able to transmit all the way up to the satellite, okay, the satellite can be a relay station, okay, but difficult and not always possible. It can also be very expensive when we actually do so. Okay, so basically, in short, okay, satellite communication is not cheap. When you intend to send a data all the way to the satellite communication, then this become a very essential. For example, you want to call for help, etc. Then you will be so-called not so-called willingly to spend the cost to send the signal all the way to the satellite, okay, and then all the way back to the Earth again. Okay, country with many islands, okay, or those a lot of hills, they are actually very difficult to connect using wire. Okay, so therefore the solution is to use satellite communication. Basically, satellites are very high altitude relay station that can access virtually any place on Earth. Okay, so basically this is for satellite communication. Okay, so basically why? Satellite communication actually has two main components. Okay, one is we call the ground segment. Okay, so basically this is what we call the ground segment. Okay, which consists of fixed or mobile transmission. Okay, basically they can be also the reception, which means that they transmit the data. They definitely will be one of the party that actually receive the data. Okay, and also the auxiliary equipment. Okay, next we have this space segment. Okay, which is so-called all the way up in the sky, okay, which is primarily the satellite itself. Okay, what is uplink, what is downlink? When the ground station send a message to the satellite, we call this uplink. Okay, you just imagine this, you actually look up to send your message. So therefore, this is what we call a uplink. The signal path from the ground transmit to satellite. So this is what we call the uplink. The downlink is basically, for example, at the angle of the satellite, you actually look down. So therefore, this is called downlink. Okay, so basically the signal from the satellite all the way to the ground receiver. So now with this, I hope you can so-called visualize what is uplink. Okay, when the ground station actually send a signal to the satellite, this is what we call the uplink. So when the satellite actually send a signal all the way back to the Earth again, we call this downlink. Okay, from here you can see that uplink typically has a higher frequency, downlink actually has a lower frequency. Why? Okay, a typical satellite link actually involves the transmission outlink of a signal from the Earth station to a satellite. The satellite then receive and amplify the signal and retransmit it back to the Earth, okay, where it is received and re-amplified by Earth station and terminal. Okay, so basically this is what it means, as I have illustrated earlier on. This is a transmitting. Basically, they transmit the signal all the way to the satellite. Okay, the satellite will properly amplify the signal. Okay, they may also process the signal. After that, they will send through the downlink to send the data all the way down to another satellite Earth station. Okay, so from here, the satellite receiver on the ground can include direct to home satellite equipment, mobile reception equipment in aircraft, satellite telephone, and handheld, etc. Okay, so why uplink basically have a higher frequency as compared to the downlink, which has a lower frequency? Okay, so basically it's from here. Okay, based on the relationship between the path loss and frequency in the RF propagation model, okay, higher frequency you actually have a higher path loss. Okay, so lower frequency has a lower so-called path loss. Imagine this. Okay, when you actually use a higher frequency, imagine this, you are going to have higher path loss. Okay, but since you are so-called on the ground, okay, you don't have so-called constraint on the resource, for example, transmission power, then okay, you actually don't mind to so-called amplify a bigger signal so that you can so-called tolerate a higher loss to send the uplink message to the satellite. So this is what it means. Okay, we can easily increase the transmit power to overcome the higher path loss. Okay, so therefore the transmitting end that has a power limitation, okay, which is the satellite itself. Okay, so the satellite actually is powered by solar panel, so there is so-called a constraint, okay, on the resource, and therefore, because of this, satellite transmission is always having a lower frequency, which means that lower path loss. Okay, so basically these are the three types of satellite. Okay, as I mentioned earlier on, the LEO, okay, low Earth orbit, basically will be the closer to the Earth. Okay, because of it closer to the Earth, the latency will be shorter also. Okay, so we also have the medium Earth orbit. Okay, last but not least, we have this geosynchronous orbit. Okay, which means that this satellite will always so-called focus at this particular region, for example. Okay, so basically, in short, this satellite will always so-called look at the so-called same location, etc. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now. Thank you.